Good morning friends. Today we'll just go for your CMOS, that is complementary metal oxide semiconductor. C represents your complementary. Complementary means it will be having both PFET as well as NFT, or P MOSFET as well as N MOSFET. It's a combination of both PFET as well as NFET. Initially what you have previously cross-checked is of the MOSFET is P channel MOSFET or a N channel MOSFET separately. Now it is a combination of both PFET as well as NFET. Okay, so this one is known as your complementary metal oxide semiconductor. Okay, before that first we'll just cross check with your PFET. Okay, so this one is your MOSFETs. If the flow of direction is outside towards the source, then it is known as a P MOSFET. Okay, in the same fashion it can be represented in a PFET with what? It is having three terminals: gate, source and drain with the bubble. If the bubble is there, then it represents your PFET, and PFET is on when input is only 0 or low. So this PFET will be in on state whenever we will be giving the input 0 towards the gate region. Okay, because always the input will be given at gate input, and at the drain we will be taking it as output, and at the source we will be giving it a power supply, that is VDD or VSS, depending upon what. If it is a PFET, then we will be giving always a VDD, and if it is a NFET, we will be always giving a VSS, that is the ground. Okay, next the same pattern for NFET. NFET means sits. If the flow of direction is inside towards the gate, the flow of electrons, then it is known as your N MOSFET. In the same pattern, NFET represented with the gate without a bubble. If there is no bubble, then it is acting as a NFET. And when the NFET is on, when the input is 1. Okay, PFET is on when the input is 0, and NFET is on when input is high. That we should be giving the input at the 2 gate regions. Okay, next. So just this one is the complementary metal oxide. So CMOS of a inverter. Okay, inverter will be having only one input and one output. Always the inverter has only one input and one output. Now we'll just cross check how the connections are being made. Okay, so this one is my CMOS inverter. Okay, always the inverter or any of the CMOS things, first we will be having a demarcation line. So demarcation line, it defines where the PFET should be placed and NFET should be. So this differentiates the PFET as well as NFET. Okay, and always the PFET should be placed above the demarcation line. Always the PFET should be placed above the demarcation line, since it's a logical high device. Okay, and NFET should be always placed below, as it is a logical low device. Okay, next we will just represents the gate, so a source and drain, and so this one is my source, gate, drain and source. Okay, initially in the first JFET, what it was mentioned, always the source should be placed for below for the NFET, and source should be placed for the above. Okay, so this one is for my NFET, and this one is for PFET. Okay, just I place one PFET and one FET. Okay, as it is a inverter. Okay, as we know that inverter is having only what? One input, so input should be given at the gate region. So I'll just shorten these two inputs, and I'll just give the input as V in. Okay, next, and at the drain the output should be taken. As we know that we'll shorten these two and we'll take the output, that is V out, V in and V out. Okay, next the two regions are being what? Source. So always we know it's a logical high device. At the source it is giving the VDD, and at the NFET is a logical low device. The source should be connected with the what? The ground. So this one is the structure what it will be looking like. Getting? So this is the structure what it is been looking: V in, V out, VDD, VSS, and the 2. So this is the structure how you got this. So this one is the Okay, next we'll just form the truth table. So as we know that V in, so we'll just take the PFET, NFET, and this one is my V. So this one is the table. Okay, we'll just check what will be the operation and how which device will be on and which device will be off. When V in is equal to 0, getting when V in is equal to 0, already we know that when V in is equal to 0, when the input is 0, my PFET will be on. Okay, so when the V in is equal to 0, PFET is on. So obviously my NFET will be in a off state. Okay, when V in is equal to 0, my PFET is on and NFET is off. If there is off, means there will be no connection between the Vout and the output. Okay, when it is on, means it is connected with the VDD. The output is there is the flow of direction. So the capacitor will be there and it will be charged to high, because the output VDD means it will be represented as 1. So we will be getting the output as 1. Okay, next, when the V in is equal to 1, when V in is equal to 1, my PFET will be in a off state and NFET will be in a on state. Okay, so an on state means there will be a connection. Okay, and here the PFET will be off state means there will be no connection. Okay, when the capacitor is charged, and that will be discharged to the ground. Ground means it will be what? PFET will be in off state and NFET will be on state and the output is 0. Okay, so this one is the the table for your CMOS inverter. If the input is 0, the output is 1. If the input is 1, the output is 0. So this one is the operation of your CMOS inverter. Okay, just for our reference, what will be the transfer characteristics? So this one will be my voltage and this one will be my current. Okay, so if the input is, so this one is my voltage and this one is the current. If the input is 0, what will happen? If the input is 0, the output is high. Okay, so the output is what here I will be representing. So here it will be what? 0.5 and this one will be by 1. Okay, so if the input is 0, the output is 1 and we will be getting the transfer characteristics like this one. If the input is 0, the output is high, and when the input is 1, the output is low. Okay, at this point my P is on and N is off, and at this point P is off and N is on. Okay, so this one is the considering all the transfer characteristics of this one. Okay, next, so why you going for this CMOS? CMOS means, so it is having a low operating power levels and it is having a high input impedance, as well as it is having a fast switching speeds.